The M3 Ultra Mac Studio is finally out. And I also finally obtained an RTX 5090. And that's not on my desk because that would be crazy. It's so loud. It's down here. I did this build a couple of videos ago. You can check it out. I'll link to it down below. There's the 5090 living inside with a little screen. Right away, let's check the power usage on both of these machines. They're both sleeping. By the way, it's got the Ryzen 9950X inside there, a really powerful, power-hungry processor too. And we're about 100 watts on that machine compared to the 7 to 9 watts that the Mac Studio is drawing while sleeping. Nobody's gonna buy this thing unless you need that RAM, that 512 gigs of RAM. Unified memory, as it's called in the Apple Silicon world. And it's unified because the CPU and the GPU both share the exact same memory. This is especially important when you're doing machine learning tasks. We're gonna kick things off with a pretty popular tool called llama. And if I do llama list, I have a few things on there, but today I'm interested in the latest models. Why not? Gemma 3, the latest, which is the small one. It's the 4 billion parameter one, and Gemma 3 27 billion. Now, before we get into this, I wanna just go over the specs a little bit here. The memory on the RTX 5090 is totaling 32 gigabytes. That's the VRAM. So if I want to keep a model completely in VRAM, which is ideal, that way the entire model can be processed by the GPU in parallel, giving us the fastest speeds. That machine has a total system RAM of 192 gigabytes. So if we run a model that's bigger than what can fit into the VRAM of that machine, it's going to spill over onto the CPU, making it less ideal because LLMs kind of need that parallel processing where CPUs don't really do that like GPUs can. So we might see a drastic slowdown. That's why I want to do this experiment. I don't know what's going to happen if we split up those models, right? So I'm going to start with these models that should all fit within that VRAM on both machines. By the way, that's not a problem on the Mac because the Mac has that unified memory that's available for everything, GPU and CPU. All right, let's kick things off. llama run Gemma 3, and we're gonna give it the verbose flag so we can see what's going on. And it's loaded up. Now you can see that this model is 3.3 gigabytes in size. It's a 4 billion parameter model, quantized down to 4 bits. And here's our GPU memory usage, the dedicated memory usage. Right now we're at 5.3 gigabytes out of the 31.5 available. All right, let's just warm it up and say hi. Hi there, how's it going so far? 99 tokens per second. That's pretty good. Let's go over here to the Mac. Okay, before I run it on there, any guesses? Write your comment down below. Which one of these is gonna be faster? Come on, I'm gonna warm this up and say hi. And there it is, 98 tokens per second. The RTX 5090 wins by 1 token per second? Yeah. In fact, these numbers are eerily close. If we take a look at the total duration, 623 milliseconds. I'm gonna show these side by side. The black screen with white text is the RTX. The white screen with black text is the Mac. So total duration is 623 milliseconds versus 657. The load duration is very different here. 25.6 milliseconds on the RTX, 61 milliseconds on the Mac. I had expected it to be the other way around. Prompt evaluation about the same. So is the eval rate, eval count, and eval duration. I'm not saying evil, I mean eval, okay? Let's go a little longer. Write a 1000 line JavaScript function and go. There it goes. 356 watts on the RTX machine, 113 watts on the Mac Studio. You can see the GPU is almost fully being used there. Not quite 100%, but pretty decent. And our numbers are pretty close to about the same. Eval rate went down on both of these. 97 on the RTX machine, 91 on the Mac. There's that nice little GPU history chart on the Mac. And there's our little GPU history chart on the PC showing that it is using mostly the GPU, which is what we want. That's ideal. You want to use 100% of that GPU. Let's say bye to our little friend, and we're gonna run Gemma 27B. You can see that memory bump right there in the memory history on the PC. That's when we loaded up the new model. The dedicated memory is now 23 out of 32 available. But look at the memory on the system. That memory went up too. Even though this model is only, I think it's 17 gigabytes in size, it should fit very nicely inside the GPU, and we still have a ways to go, but for some reason the memory went up too, the system memory, not the GPU VRAM. So I'm not sure why that is. Is it going to use some of the system memory? But we're about to find out because I haven't run this before. The memory pressure on the Mac is negligible. We got 512 gigabytes of memory there and 70 gigabytes of memory used so far. Let's warm it up by saying hello. And boom. Okay, how about that power usage? About the same. 40 tokens per second on the NVIDIA RTX. We went down quite a bit because we went to this new model that's much larger. And you can see that our dedicated GPU is almost at the limit there. And this model is only 17 gigs on disk, but it doesn't mean that that's how much it is going to be when it's running, because there's other variables. In fact, I recently made a calculator to calculate how much RAM you approximately need. Yeah, it overestimated a little bit, as many of you mentioned in the comments, but it's since been corrected. It's a little bit more calm now. I'll leave that video down below, and that calculator is available to use as well. It's open source too. Thanks to those who contributed, by the way. Look at our system memory on the PC. It says we're using 34 gigabytes. Where's that going? Maybe it's the way it's reporting the memory, because the total system RAM is 192 and the total GPU VRAM is 32. So it should be reporting whatever is being taken up from that 192 up here and what's taken from that 32 down here, but maybe it's somehow combining them. Anybody know the answer to that? Leave a comment down below for that. I'm sure people would appreciate it. Thanks. Macs never seem to have enough ports, especially for software devs who often juggle multiple devices, screens, and peripherals. The Baseus Spacemate 11-in-1 docking station solves that problem. This award-winning docking station is ideal for developers needing extensive connectivity. Yeah, you heard me right, award-winning. Just look at this sleek design. And this thing is solid. It's built like a tank. It's got a magnetic base with a base adhesive to prevent the dock from tipping over when you're plugging stuff into it. And it provides 11 versatile ports. That's right, 11. That includes HDMI, high-speed USB-C and USB-A ports, Ethernet, an audio jack, some more on the front there, and it even supports 100-watt USB-C charger. Triple display capabilities means vibe coding, vibe debugging, and vibe monitoring applications across 3 4K 60Hz screens, all at the same time. The built-in LED screen indicates which ports are active, and it has this one-click screen lock button that helps instantly secure your display. That's perfect for stepping away from sensitive code or client data. It's the Baseus Spacemate docking station. I've got a Mac version here. There's a Windows version as well. So if you're ready to upgrade your dev environment, check it out in the link below and streamline your workflow. Okay, what happened on the Mac here? 27, 40 on the PC, 27 on the Mac. This time it's not close. And this aligns a little bit more of what I expected to see, which is that the RTX machine would be so much faster than the Mac. So what's the point then? The Mac is a $10,000 machine. The RTX 5090, oh wait, the RTX 5090 is a $3,000 card now, if you can get it. Maybe you can pay $4,000 or $5,000 even if you try to buy it on eBay. But let's just say it's the 2,000 MSRP, okay? Whatever they announced when they announced these things, which is not, or is it? It's not even available at this point. I waited for months to get mine. But why would you get that Mac? Well, let's keep going. I'm gonna switch over to another popular tool called LM Studio. And in fact, what I want to do is compare the results that we got in LM Studio with llama, because they're not gonna be the same, most likely. There's different kinds of overhead that's taking place and different kind of settings that's being defaulted to by each program. That's not even proper English, but you know what I mean. We're gonna kick things off with Llama 3. Hi. Okay. This is interesting. Because it's a small model, it's not super smart, so it gave me the exact same answer on both computers, but not the exact same speed. Check it out. On the PC, we've got 93.9 tokens per second. And just to remind you, we had 97 tokens per second in llama. So a little bit slower in LM Studio for this one. And here it is on the Mac. We are getting 100 tokens per second on the Mac. Same exact model, same exact response. And this was initially 91 tokens per second in llama land. Let's switch over to another model, the bigger Llama 3 27 billion. Loaded it up and we see the memory rising accordingly. Let's warm it up and say hello. And there it is. It's going pretty fast. 41 tokens per second. Very nice. Let's see if it gives us a different answer here, because it is a larger model. It's supposed to be a little smarter, but who knows? Notice that when I load this, it does still offload all the layers, all 62 of them, to the GPU. So it's detecting that the GPU is enough to load the entire model. Same thing on the Mac. Let's say hello to it. Hi there, how can I help you today? Ooh, you know what? Maybe it's not such a smart model. It gave me the exact same answer, but you know, that's okay. Maybe it's not meant for saying hi, but maybe doing actually useful things. 41 tokens per second here in LM Studio, which is a little bit faster than the llama version. That was 40 tokens per second. About the same, margin of error. But here and on the Mac, same kind of difference. 28 tokens per second in LM Studio, 27 tokens per second in llama there. Now, what about something bigger? This model right here looks big enough. DeepSeek R1 Distill Llama 70B. This is a 70 billion parameter model, and it just happens to be 39.6 gigabytes on disk. And if it's that much on disk, you know it's gonna be bigger in RAM. So you know that it's not gonna fit in our little 5090 GPU. And LM Studio knows that. And it's telling us that the GPU offload it recommends is 39 out of 80 layers, which is about half. So half of this is gonna go on the GPU and the other half on the CPU. Let's load it up and see how that affects everything in the world. Life or death. Here we go. I'm gonna load the same model up here on the Mac Studio. Here it's telling us, oh, GPU offload is going to be 80 out of 80. But does it matter? Maybe. Let's see what it looks like 80 out of 80. And there it is. It's loaded up. Looks like 70 gigabytes is being used out of the 512. That's total on the system, by the way. That's not just the VRAM. The VRAM is down here in LM Studio. It says 41 gigabytes. Fine. What about over here? This is kind of odd. This one's telling me that 22 gigabytes. Oh, silly me. Yeah, because we offloaded only half. So LM Studio is reporting correctly. Let's take a look at Task Manager here on Windows, and we've got 23 gigabytes out of 32 available for the dedicated GPU being used, and system memory is being used too. Let's just say hello. And over here too. Wow, 13 tokens per second on the Mac Studio. That's kind of still usable, I think. Not bad. What about the RTX machine? Well, this is where things change. And here we got 1.8 tokens per second. At this point, it's not in a usable situation. You can see where it was processing on the CPU and on the GPU. So that's definitely being shared by the two processing units. One is just the GPU and the other one is the CPU. I already said that. You know what I mean. Write a 1000 line JavaScript function on both and let's go. Okay, let's see. This is a thinking model, so it's gonna be doing some thinking. That one is also thinking. Thought for 7 seconds, creating a 1000 line JavaScript function, and it's off. For the Mac, this one is still thinking. 13.3 tokens per second over here. It's done on the Mac. This one is still thinking. What's it thinking? Oh, it's complaining that writing 1000 lines is impractical here. It would be too lengthy and hard to manage. I mean, definitely true. I wonder if it's gonna write the same exact function. Probably not. Take a look at the CPU here on this machine. It's definitely taking that brunt of that force right there. The GPU is not doing too much. It's only at 7% utilization, which I thought it would be a little bit more than that. But I think the CPU is doing a lot of the lifting here, unfortunately. Now, if we take a look at the Mac CPU history, oh my God, there's so many cores. Have you seen that many cores? 32 cores? Oh my gosh. Let's just do another quick thing here. That one's still thinking. So yeah, there's pretty much nothing in the CPU history on the Mac because, well, it's all happening on the GPU. That's what we want. And that's what more RAM allows us to do. After all that thinking, you're complaining that you can't do it? I can provide you with a smaller, more manageable JavaScript function. Fine, just write something. Oh, you know what? Now that I go back here, it says creating a 1000 line JavaScript function is not very practical. So the Mac also thinks that. Yet on the second attempt, it proceeds to write it. Anyway, I wanted to test one more thing. What if we start a new one and load up that 70 billion parameter model on the Mac, but do only 39 layers on the GPU, just like the PC? Let's see what would happen. Load that model. That means the rest of that should be on the CPU and should also slow down. But is it gonna slow down? And by how much? That is something I don't know. Quick hello, as usual. Nice to be polite to these models. 7 tokens per second. Wow. Do you know what this means? Look. Even the performance cores, the CPU cores, actually got hit with that query. So it's actually working. It's splitting up the model. And not as much GPU usage on this one. Yet, we got 7 tokens per second instead of 1.8. You know what's happening here, right? This is that unified memory of the Mac at work. So if you're gonna be running larger models, anything larger than would fit on the RTX 5090, which is already at 32 gigabytes in VRAM, you're gonna not wanna do it on the RTX machines. Or you're gonna need to get a professional grade video card like the A6000, the ADA series, which go up to 48, and then the H100s. You're welcome to get that $30,000 card, which goes up to 80 gigabytes, which means that if you want to run a model that's more than 80 gigabytes, you still need to buy another one of those. Now we're $60,000 in the hole, and we only have 160 gigabytes of VRAM. We can buy 6 of these Mac Studios for that price, put them in a cluster like this one, and have, well, over 3,000 gigabytes of RAM available. So this is why people are getting these Macs and people are excited about these Macs. Not because it's necessarily faster, which it may or may not be. It's close, it's pretty good, but most of the time it's not for smaller models. But if you want to run larger models that are more capable. In fact, I ran the full DeepSeek on that in the other video with the cluster. So if you want to check that video out, I'll link to it over here when it's ready. It's a big one, so it might take a while. Otherwise, it'll be another video that you might enjoy right over here. Thanks for watching this one. I'll see you all next time.